Recording in progress. Okay. Welcome, everybody. We have a lot of participants today. Not. Um, to my basic chemical principles class. As a reminder, I didn't open up my thing, did I? As a reminder, I am I'm doing this as a kind of a service. This is not transferable. This is not college credit. It will be college level. It will be the equivalent. I've taught this course before. In college, you have your general chemistry, which is a 2-semester or full year general chemistry course. And then you have this course. This course is basically chemistry for non-majors. It is designed for people who have no background in chemistry, little or no background in mathematics. I say a lot, and I need to stop that habit. So there we go again. A lot of times, students who are going into general chemistry will take this course first if they've not had any chemistry background before. So I have no assumptions of anybody's knowledge of what they already know. We're going to use some algebra, but not a whole lot of it. I'm going to try something here because I just realized I wanted to talk about the syllabus today and I didn't bring it up. There it is. What's your screen doing right now?
Nothing.
Are you still seeing me?
I'm still seeing you.
Okay, fair enough. So, my intention for this course, I've always been about education. I've always loved science and mathematics and all that kind of fun stuff. And I also realize that I'm kind of a freak. Not everybody loves science the way I do. And in fact, I know a lot of people are intimidated by it. And I've always been one who has wanted to reach out and help other people. So one of the assumptions that I've had, which may or may not be valid, but I've always assumed that a lot of parents, for example, are kind of intimidated with science and with chemistry. So anyone who wants to help their children with their science or chemistry homework might feel a little uncomfortable. That's my assumption. Because of COVID now, more and more, well, COVID and other issues, more and more parents are now going to homeschooling and may feel uncomfortable when they have to talk about the sciences. They are, I assume, more comfortable with biology, which is my worst subject. So, no, I'm not offering anything on biology. But I'm a physical scientist by training and by trade. My degree, which is, this degree here is my bachelor's degree. That's just plain chemistry. This is my doctorate. Yes, I am a doctor for those who are not aware. I have my PhD from Boston College in theoretical chemistry, which even amongst chemists is, sort of makes me a freak. Theoretical chemistry is the borderline between chemistry and physics. It's very heavily mathematics based, and chemistry can go sort of one extreme to the other. There are types of chemistry like organic chemistry, which have almost no mathematics in them at all. Percent yield is about the most you'll ever do, all the way to physical chemistry, which is what I do, and it is rather extreme chemistry. In my thesis, for example, I've had I put equations in my thesis that would be 2 or 3 pages long, just all math. So it looks really intimidating. It's actually a lot easier than you might think. But again, I'm kind of a freak. It's the kind of thing I enjoy. So there it is. So today, so this course is for people who want to feel more comfortable with science. It's for people who are curious about chemistry. There's a lot of interesting things about chemistry, and people will find little blurbs and little articles that spark their interest, but really don't understand, I believe, don't really understand the nitty gritty, the details of it. Because this is not an accredited course, I am not authorized by any institution of higher education. I applied for accreditation, but my accrediting body was just lost their license. That's sort of a joke. I don't know if you keep up with the news or not. There isn't an accrediting body there that is no longer allowed to give accreditation. So yeah, that's where I applied. So I don't know. I don't know where to apply now. It's kind of sad. You believe me, right? Okay. It's like a joke. It's just smaller. Okay. Because this is non-transferable, because I am not assigning a grade, that means I am not assigning homework. I am not grading. I'm not doing quizzes. I'm not doing exams. The amount of effort that you put into this course is entirely up to you. I get the feeling that if anybody is watching this, most people, not all of them, but I expect that most people will not be doing homework. The advantage of doing homework is that it's going to help cement concepts for you. And I'm more than happy to answer questions if you don't know how to do homework, a particular homework problem, but keep in mind that your book may be different than mine. So I don't have answers off the top of my head. So if you ask me a question, we can work through it. Just be a little bit patient. Okay. Any questions so far?
Not from me.
All right. We have one person and one person only online with me today. Her name is Kim. She's my friend. She's been my friend for quite a long time. I have asked her to play a special role because I know I've gotten some really interesting responses as far as interest goes in what I'm doing. But I get the feeling that 10 o'clock on Tuesdays and Thursdays, a lot of people are probably at work or at school. Not a lot of people are going to be here live. So I've asked my friend to be the voice of everyone else to make sure she asks any questions she has, makes any comments she wants to make. I have done, or I've tried things like this in the past. It's gotten little or no interest. I intend to run this through the entire term, which will end December, I think. I forget the exact schedule. We'll go through the syllabus here in a minute. But it would really help me to know if anybody is actually watching, whether you're live or not. And if you're actually getting anything out of it. I don't want people to waste their time on this. So if you're watching this, if you're enjoying it, if you're learning, if you're actually learning something, please reach out and let me know, even if you're not live. I'm planning on posting these videos to YouTube. You can send me messages. I don't know if YouTube has like comments or not, but or likes, but somehow get me the message that yes, you are watching and yes, you want me to continue. I'm not going to waste my time if nobody else wants me to be doing this. So just let me know. You can ask questions offline. I think most of you, if YouTube can do comments, you can put comments and ask your questions there. If you know me personally, You can text me or email me anything you want. More than happy to help. That's why I'm here. Okay, that being said, we ready to get started?
Yes.
All right. I am going to share screen. We're going to start off with the syllabus. Yes, I am running this as if it is actually a university course, which means that I have to have a syllabus. Now, the syllabus is a contract between the student and the faculty member. A lot of people don't really realize what the syllabus is. Always a good idea to read the syllabus. Now, of course, here there's no real consequences. You're not, if you do homework, it's on your own. I'm not grading anything. There are no exams. But when you take a course, always read the syllabus to find out what to expect. And if you see a problem, if there's something that concerns you, ask your professor early first week, first day if you can. If it says that there are 2 exams and you feel like you would like more exams because you're not comfortable that you can do well, usually students don't do so well on the first exam. This would be the time to say, look, I see you only have 2 exams up here. Is it possible to change the syllabus to make more exams, like maybe 4? Or something like that. So always, always, always read the syllabus. It's your contract. Would you sign a contract without reading it? I hope not. Although we all kind of do. Every time we have software, we always scroll to the bottom, say accept. Anyway, now, syllabus is a little more serious than that. There was actually a software company that put a line in the middle of their agreement that says, by accepting this agreement, our company now owns your soul. And there's a little button where you could click to opt out of that line. And 5 people clicked that button, and they actually did something nice for those 5 people. But yeah, no, we're reading, so we're going to meet every Tuesday and Thursday. No office hours, but I just told you how to get hold of me. I did provide an email here, which perhaps I should not, because I'm going to open this up to the entire world. So it could be kind of interesting, don't you think?
Yes.
Anyway, this is not, we're in a litigious, is that the right word? Where people sue each other in litigious society. So I want you to note that this course is not approved by any accredited institution and will not provide transferable credit to any institution of education. So no, I'm not going to write a letter for you saying you've completed my course. No, I'm not going to provide a grade. This does not provide transferable credit. My original idea was to help parents to better understand the discipline of chemistry, to feel more comfortable with it. I've said that already. But interestingly enough, I've had more than one parent ask if their school age kids, middle school, can take this. Yes, there are middle school kids who are certainly sharp enough that I think they could probably do it. And with little, we're gonna do a little algebra, but it's nothing really major. I don't think. So they may struggle a little bit with the math, the concepts. Concepts should still be there. No specific background or prior knowledge is required when I teach this specific course. Basically, this is for people who lack background to take general chemistry. So you don't walk into it saying, okay, by now everybody should have finished calculus and physics. No, I'm not assuming anybody has a background, so you'll be fine. The textbook. Okay, we'll talk about that in a minute. Now let's talk about it now. The textbook that I'm using, I don't follow the textbook explicitly. But I'm using this textbook. This is General Organic and Biochemistry, 4th edition by Denniston, Topping, and Carrot, or Carray. I don't know exactly how that's pronounced. You don't have to use this book. There are lots of books out there. The key is to look for a book that covers general organic and biochemistry. When you're a chemistry major, general chemistry takes an entire academic year. That's 1 year. Organic chemistry takes at least 1 full academic year, so there's 2 years. Mine took 2.5. Biochemistry takes at least half an academic year. Some will take an entire year. So this book covers what majors would take in a minimum of 2.5 years and as much as 4.5 years. Obviously, if that's the case, this book covers a breadth of knowledge, but not a depth of knowledge. Every book like this, every general organic and biochemistry book, is designed for people with no chemistry background. I have another one actually in the closet behind me. So you can use any book you want as long as it's a college level book, which they all are, general organic and biochemistry. We are only covering general chemistry. It is not worth spending a lot of money on this, so it's a good idea to go and see if you can find one in a secondhand bookstore. Something like that. Now, if you get a textbook that I don't have, which you probably will, that means that any questions on any homework that you have, I'm not going to have access to. So you'll probably have to type out or screenshot or do something, take a picture so I can see the entire question that you're asking. But any textbook will work. If you use a textbook other than the one I'm using, the order that the material is covered may be different, which means when I'm covering a topic, when I'm covering thermodynamics, and I'm in chapter, whatever chapter that happens to be here, your book may be a different chapter. So you're gonna, if you don't have this specific textbook, all that means is look at the index, look at the table of contents, find the appropriate section, and it's there. I don't teach out of the textbook. I never have. I've had students ask me why I don't write my own textbook, and I've been tempted. But I won't, because if I wrote my own textbook, I couldn't teach out of it. I would not teach with my own textbook, because in my opinion, the textbook should provide a different voice. If I use my own textbook for my students, the students would be hearing the same voice in the book as they're getting in lecture. Different materials can be covered in different ways. And if the way that I cover it in class is not something that makes sense to you, you should be able to find it in your book and see if the way that it covers it in the book does, because everybody learns differently, and I understand that. If you don't understand what's in the textbook and you don't understand what I said in class, it's my job to help you understand. That's the time to come to me and say, look, I still don't get this concept, and I am happy. Back when I taught, and I would be happy to set up a special Zoom meeting just for you if you needed it. I am more than happy to go over the material and see if I can't find a way that helps it to click for you. That's my job. So don't be ashamed. Don't be afraid of that. While we're at it, if I say something ridiculous, like I assume you all know this, and you don't, if I assume that you have some prior knowledge of science, something basic, if I say everyone knows the law of conservation of energy, and you've never heard of it, whose fault is that? Is that my fault? Is it your fault?
No.
It's nobody's fault. If I assume that you know something and you don't know it, that's a failing of the educational system. That is not your fault. And that means you should not feel ashamed to interrupt and say, oh, wait a minute, can we talk about that? I don't know that. I'm happy to. When we start getting, I'm expecting this will go viral. So by Wednesday, I should have about 3.7 million followers. Anyway,
Okay.
if we have a whole bunch of people, I'm going to make up some sort of a rule about how to get my attention to ask a question. Right now, we have one student. So that one student is free to leave her microphone on and interrupt me anytime she has a question or comment. It's probably more efficient that way. So yes, feel free to interrupt and feel free to ask your questions as you have them. Any questions so far?
No, sir.
Okay. Oh God, don't call me sir. Butthead if you're. Okay, so best study practices. All right. Doing homework will help you to cement ideas. So find the section, don't do all the homework all at once. Find the sections in the homework assignments of things that we've covered in class and do some of those. Every textbook has questions where they have answers in the back and questions where they don't have answers in the back. Do the questions with the answers in the back. That way you can tell if you're doing it right or not, assuming that you're doing homework. If you want to try some of the things that don't have answers in the back, feel free. And if you're not comfortable that you got the right answer, let me know. I'll let you know if you got it right or not. I'm not, don't send me the whole thing and say, here, grade this. No, I'm not going to grade it. But if you want to know, hey, did I do this one correctly? Let me know, and I'll look at it for you. The best way to prepare for this course is to read the textbook. As we go a little bit further down, we're going to have a day-by-day schedule of what we're covering. It's best to read the textbook several times before class and then after class as well. When I say read the textbook, though, when I was, it wasn't until I was actually teaching that the head nurse in the college, I was talking with her and she said, do you know how to read a textbook? What an insulting question. I have my PhD. See? Yes, I know. I didn't get my PhD by having my roommate read to me at night every time before I went to bed. No. Well, as it turns out, I was not reading the textbook correctly. There's a right way and a wrong way to read it. You don't read textbooks like a novel. You don't look up significant figures and read it from word 1 all the way to word 2. And oh God, he wants us to do this 3 times. Is he crazy? What is crazy is I used to have glasses, but apparently now I don't. Oh, there they are. Anyway, here's how you read a textbook. And I don't mean to sound insulting because I know you know how to read. Textbooks are different. So when you read a textbook, first of all, go through and look at all the pretty pictures. So I'm in section 1.2, matter and properties, and I look at all the pretty pictures and I read the captions. All of the pictures, all of the captions are related to the material in the book. So if you go through section 1.2 and just look at the pictures and read the captions, you've done it once. You've read the textbook once. You've read that chapter. Then go back and read it a second time. Read the title headings. Matter and properties is 1.2, which covers matter and physical properties. I'm not even going to read anything else. Matter and chemical properties. Intensive and extensive properties. Here's the thing. Students get lost when they hear words and terms that they are not familiar with, which they're not familiar. And I say it that way because you're not supposed to end a sentence with a proposition. Anyway, I just read a title here, intensive and extensive properties. All you're reading is the heading. So terms like that should not be intimidating. It's just the name of the title. But because you've read it once, intensive and extensive properties, those words are now buzzing in your head. You've heard them before. Classification of matter. And guess what? We've just read the chapter a second time. We're already done with reading it twice. Now, how well do you remember English? English class, I should say. Because when you write a paragraph is always supposed to contain a minimum of 3 sentences. Well, I'm not talking about writing like a novel. I'm talking about like a textbook. The first sentence is always, what are you going to say in this sentence? The second sentence is, here's what I'm saying. And the third sentence is, here's what I've said. Remember that? So as you go through and read it for the third time, just read the very first sentence. There are 3 states of matter: the gaseous state, the liquid state, and the solid state. That's it. That's what that whole paragraph is about. Let's go to the intensive and okay. An intensive property is a property of matter that is independent of quantity of the substance. I can read more if I want to, but after that comes the examples. So that first sentence tells you what an intensive property is. The very next paragraph, an extensive property depends on the quantity of the substance. Now you're getting the definitions. If you do that, just read the first line of every paragraph, you've read that chapter 3 times, and it takes almost no time to do it. You can stop there, but the next pass through is when you read the rest of the paragraph. So if you just stop there, in your head, it may not even be cemented yet, but now you've heard the definition of intensive and extensive properties. And when I talk about it in class, if I talk about it in class, because I don't cover everything in the textbook, if I feel like it's covered well enough, I may pass. But when I talk about it in class, it's going to sound familiar to you. That is going to open up your mind to understanding what that really means. So read the textbook before class. Once I have talked about it in class, go back and read it one more time and just see, does it make more sense the way the author puts it, or did it make more sense in class? Doesn't really matter. I don't care how you get the material. I want you to get the material. I'm not one of those professors that says, you must solve this problem using this approach. No, you know what? You can have your own approach. You can use the approach of the textbook. You can use the approach that I show you. You can use an approach you've used in the past. If you are using an approach to solve a problem, let me know. Because if it turns out that there's a weakness in your approach, I will warn you about it. A lot of people used to try to solve problems exclusively using cross multiplication. Cross multiplication fails for the gas laws. Sometimes, not all of them. Sometimes it'll fail for the gas law. And I will warn you about that. I will say, okay, cross multiplication, it was wildly popular for a while. Here's some of the drawbacks. I'm going to teach you one method for solving problems. It's called the factor label method, or sometimes it's called unit analysis. It is a general mathematical approach to solving word problems, to solving problems. Not just for this class, but for any class you're going to take. It has weaknesses, and I'm going to warn you about those weaknesses as we learn it. But generally, it is an excellent approach to solving problems, and it's the one I will use when we do math in here. By the way, whether or not you choose to do math, that is your choice, because it is your choice as to whether or not you are going to do homework, right? So why would you need to learn math? The reason I'm going to go through solving problems mathematically is mainly is proof to you that it can be done. Science is experiential. It's all based on experience. Sitting in a class like this, it is all too easy to assume or to just lose sight of that. You know, it starts getting hypothetical and theoretical, and you forget that everything that I'm going to talk about is based on experiments, based on observation. It's based on what my cat will see and hear. What are you doing, silly? Okay. So yes, you can come up if you want to come up. Come on. So anyway, yeah, it's all based on experiment. And by the way, science is not truth. Science is not truth. People have a habit of assuming that what you learn in science class is truth. It is not. Every scientific thing that I teach you in here, every theory, every principle, it's not truth. And people who don't understand this will try to use it against science. See, you don't know. Well, no, we don't. What we have is a body of experiential data. We have experiments, we have observations, we have all of this experience. And when I teach chemistry, when I teach atomic theory, I am teaching the best model that best encompasses and explains that body of evidence. That's all science is. It's just a model that best fits what we have witnessed, what we know, not what we know. I'm going to try to avoid using that. But it's just a model that best fits what we've experienced. Every scientist worth their weight in spit understands that tomorrow, some particularly bright young kid, maybe one of you, could come along and prove that atomic theory is complete nonsense. We live understanding that. It doesn't matter how fundamental the laws are. I just got done teaching a course, actually a couple of years ago now, where I just blew my students' minds. It was a senior level college course. And I opened up with, you think you know something. It was amazing. I loved challenging what they think they understand about science. And I basically demonstrated to them that we don't know anything. We know we don't know some things, but it's all just a model. It's all just, and it's kind of an incredible thing. You can't be in front of my camera like that, sweetheart. Okay, that's my cat Star. She has itchy skin and is missing patches of her fur, aren't you? Because she scratches too hard. And I'm treating her for that. So don't think I'm abusing my cat, because I'm not. I just do terrible things to her with a fork. Okay. That's an old Steve Martin joke. Any questions about study practices, the textbook, anything like that? All right, moving on. If you miss a class, well, you know that I'm recording this. I'm going to try to put it up on YouTube. It is incumbent upon you, if you are not here in person, to learn the material on your own. I'm not going to repeat lectures for anybody who's missed a class. I've had students walk into my office and say, I couldn't be there on Wednesday. Can you tell me, what did you do? No, I'm not going to repeat my lecture. I did that on Wednesday. I'm not doing that. Homie, don't play that. Oh, I'm sorry. I shouldn't say. It's probably a racist phrase by now. Anyway, no, I don't do that. I am not going to repeat lectures. It is up to you to watch the videos, If you know someone else taking the course, get together with that person and say, what did that jerk cover in class? Get the notes from someone else. Make sure that the question just came up. How soon after you have the live class will it be available to watch? I honestly don't know. I've not done this for a while. No guarantees. No guarantees. I know that it takes a couple hours just to convert the video. And I've kind of forgotten the process for loading it up to YouTube, but if I forget to load one, or if I've fallen behind, feel free to reach out and let me know and say, you haven't done this one yet. Oh, sorry. Okay. Sometimes I, don't upload things as quickly as I should. So keep me honest. Anyway, yeah, if you get the material from someone else, if you watch the video and you have a question about it, then I'm more than happy to go over any specific question you might have. Get your butt out of my camera. Then I'm more than happy to go over questions you have. I'm just not willing to repeat the entire thing. Okay. Schedule. This is the tentative schedule. It is subject to change. Schedules are always subject to change. I do not have a crystal ball. I cannot sit here today and predict if we will be on schedule or not 3 months from now. I try very hard to stay on schedule, honestly, but sometimes I may be a little ahead. In fact, I'm guessing that we will, because when I get ahead in a lecture, I will continue on in the order of what we're talking about. So I get the feeling we're going to start chapter 1 today, this morning, sometime before the end of this lecture. But this is what I expect to cover if my cat will let me. Out of my way, silly. So yes, we're going to cover the scientific method and measurements, the significant figures, and the factor label method is all chapter 1, split up into Thursday and next week. The reason I'm going to cover significant figures, if you are not doing homework and we're not having exams, you may think to yourself, I hate significant figures. Someone has tried to teach it to me in the past. I'll skip that part. You're allowed to do that. That's okay. But we're going to cover it in class, because remember, my goal is to help parents teach this stuff. Or when their kids come home and say, Mom, we're covering significant figures. You may not be an expert in it by the end of this class, but at least you will be familiar with it. And that's my goal. I want you to feel a little more comfortable so that when you go and look at your child's textbook, homework, notes, what have you, I'm hoping it'll come back to you and it'll help you to make a little more sense of it when you need it. So yes, we're going to cover things like sig figs, because you may well come across it. And then we're going to get into chapter 2, which is matter and the atom. And you may ask, what's a matter? And I would answer, nothing. What's the matter with you? That was like a joke. It was just smaller. I don't have a lot of days off, but you'll notice that election day, I am not holding class on election day. I personally believe that election day should be a national holiday. Therefore, I'm going to treat it as one. If you think it's unfair of me to take an entire day off when the institution does not, I will be more than happy to refund your money. No, I'm not charging for this. I should, honestly. I do need the money, but I'm not charging because, frankly, I'm just trying to help. I just want to help people. Special topics. Special topics, I always build these into my syllabus, typically 1 or 2 days. I've had as many as 3. I call them special topics because I don't know if I'm going to be falling behind or not. So special topics are basically my makeup days. If I'm falling behind, that gives me a couple days where I don't have anything specific scheduled. We can cover anything on special topics day. If there's a subject you want me to cover, if you want to learn how to make an atomic bomb, I've taught students how to make atomic bombs. It's remarkably simple. You may be a little worried now saying, oh my God, did he teach people how to make an atomic bomb? Yes, I did. You can make it in your garage. It's trivial. But the hard part, and this is why I'm not worried about it, the hard part is getting the fissionable material. The hard part is getting a fuel that is pure enough that it will explode, which it takes the resources of a nation to actually purify weapons grade uranium or plutonium to actually make an atomic bomb. But anyway, that's it. I mean, we can special topics. We can talk about anything. We can talk about how medicines work. We can talk about anti-tumor medications. We can talk about anything you want. We can talk about how cancer treatments work. I'm kind of stuck on cancer today, and I don't know why. But yeah, anything that you hear throughout the year and think, oh, that looks like that could be interesting to talk about in class, bring it up. Ask me to talk about it. And we have time. We'll do it on the special topics if it's appropriate. And so it's say the syllabus. Before I end the screen share, do we have any questions on the syllabus?
Not from me.
All right. The Navy did a study. It said that the typical person can maintain focus for about 40 minutes. This class is scheduled to be 80 minutes. So my question to you, should we schedule breaks, short breaks, or not? I'm thinking 5-minute breaks.
Can I vote?
Yeah, you can vote. You're the only one here. You're the only vote that matters.
I would be for doing a 5-minute break.
All right. Well, here's where we are. We are 40 minutes into an 80-minute class. I am going to stop recording, which will also be kind of an interesting thing for me to try because we'll see what it does when I do this. And let's take 5 minutes. Let's come back at 10:43 now. Let's come back at 10:50. That'll be a 12-minute break. 10:50?
Sounds good.
All right. Star, I swear to God. Welcome back. Okay, so let's get into it. Let's talk about this. I can't tell you that joke because I already told it to you. So what is chemistry? Why chemistry? Chemistry is the study of matter. What's a matter?
Nothing. Is anything the matter with you?
There you go. Like a joke, it's just smaller.
Almost.
Matter is anything that has mass and volume. You will see that what I am doing is using a very cool little device I have. Oh, come on. Well, that's no good. Okay, I'm having technical difficulties with my device, which is very sad because there we go. All right. This is called the Remarkable. It's basically an electronic paper tablet. It doesn't have colors. It's just black and white. Does not connect to the internet. Does not have apps. does not have games. It's designed to help people focus. The advantage of it is that as I'm using it, I can actually export this as a PDF, which means that if you want a copy of my notes, I can provide them to you. But honestly, the best thing to do is to take your own notes. You'll get more out of it because you're seeing it here, you're hearing me, and as you're writing it, you're getting mechanical practice, which will all help you to maintain to get more out of this class. So chemistry is the study of matter. We're going to talk about the other sciences in a moment. And matter is anything that has mass and volume. Mass is quantity of matter. It is actually how mass is defined. Mass is quantity of matter. A lot of people confuse mass with weight. They are very, very closely related. The higher the mass, the higher the weight. But the difference is weight is a force. Specifically, weight is equal to mass times acceleration due to gravity. And here's the big difference. Acceleration due to gravity on Earth, the acceleration due to gravity is 32 meters per second per second. No, 32 feet per second per second. An acceleration is how fast velocity changes. So if you take my glasses and you drop them, they will accelerate. In 1 second, they will be falling at 32 feet per second. In 2 seconds, they will be falling at a rate of 64 feet per second. So they're accelerating as they go down, as they fall. And how quickly they accelerate is a matter of which planet you're on. On a smaller planet like the moon, which is technically not a planet, the acceleration is going to be smaller. The heavier the planet, like on Saturn, the faster the acceleration will be. So weight will change depending on what planet you're on. Which tastes better, Earth or the moon? Well, the moon is just a little meteor. Anyway, as it turns out, here on planet Earth, weight changes because of centrifugal force. As the planet evolves, if you are standing on the equator, because the planet is rotating, centrifugal force is trying to throw you off the planet. It doesn't get very far. You're not going to get very far, but it makes you a little bit lighter than if you're on a pole. Because on a pole, the centrifugal force is 0. So you're going to be heavier on the North Pole than in Hawaii. That's why we all should move to Hawaii. Mass, on the other hand, does not change. It is the same mass no matter where you are on Earth, no matter what planet you're on. The mass is always the same because it is quantity of matter. So if I take these glasses, and let's say they're 15 grams. I honestly don't know. I've not weighed them. But let's say that, I've not massed them, I guess is the term. But let's say these are 15 grams. The mass of 15 grams will still be 15 grams on the North Pole. There'll be 15 grams on the equator. There'll be 15 grams on Venus. They're 15 grams because the mass, the amount of matter, does not change. So there is a difference between mass and weight, although they're very, very closely related because of this little formula here. Volume is a little more challenging to explain, and we all know what volume is, but if you've never really thought about it, I actually don't even know the proper definition for volume. And no, I don't believe people should memorize definitions. People should know concepts. I don't care. I used to teach this kid. Well, I didn't teach him. I watched him after school. He was a brilliant kid. He was in middle school. In exchange for room and board, I would babysit him. Yanni was his name. And he was going to an elite school. And he came home one day and he said, "Hey, I am having a quiz over these meteorological terms. Can you quiz me on them?" Well, yeah, I can do that. I'm happy to. And so I looked at the sheet and I said, "Okay, Yanni, what is a cumulus cloud?" And he repeated the definition verbatim, word for word, exactly what was on the sheet. And after he said it, I said, "Okay, what does that mean?" And his response was, "We don't have to know that. I have no idea." Did he actually learn anything? Here he is memorizing definitions, and he didn't learn a thing because he didn't understand the concept. I don't care. I never will, of course, we're not taking quizzes and exams, but I've never cared if a student could repeat an exact word for word definition. I want them to understand the concepts, because if you understand the concept, you can make up a definition. That's what I do when I teach. I don't give exact definitions. Well, I just did for math, I guess, but that one's so obvious. But I make up definitions because I know what the word means. I know the concept. Volume is an effect of the third dimension. That is not a definition. So it's a third dimensional effect. Go away. You're being a total nuisance today. No. Sorry. I'm sorry. I know you don't want to be on the ground, but you have to stay off my lap. Okay. Sorry. Okay. I've Diet Coke all over the floor. So here's what I mean by this, and this will help you at least understand what volume is. In one dimension, we have length. Let's say we have a length of 1 centimeter. That's one dimension. So if length is one dimension, what do we have in 2 dimensions? Okay, not a fair question.
2.
Well, we have no.
Oh.
No. You're being too much of a bother. Okay, so I apologize for my obnoxious cat. Usually she's not quite so needy. I don't know what the deal is today. 2 dimensions we have, well, let's do it this way. We have like 1 centimeter by 1 centimeter, because now we can go not just along the x-axis, but along the y-axis. This is an area. So in 2 dimensions, we have area. What's the area of this little square that I just wrote? Well, you just multiply the 2 sides together. What's 1 times 1? 1. But you also multiply the units. So 1 centimeter times 1 centimeter is 1 centimeter squared. So our volume is 1 centimeter squared. So in 1 dimension, we have length. In 2 dimensions, we have area. In 3 dimensions, we have volume. That's what I mean when I say it's a fact, it's an effect of the third dimension. Every dimension has sort of a corresponding idea. Length for 1, area for 2. In 3 dimensions, it's volume. The area of this volume one times one is what?
1.
Yes. And how many centimeters? So it's not centimeter, it's not centimeter squared. It now becomes centimeters
3.
cubed.
Cute.
1 cubic centimeter sometimes in medical shows, a cubic centimeter is 1 cc. Give them 30 cc stat. That means 30 cubic centimeters. And 1 cubic centimeter also happens to be the definition of 1 milliliter. So 30 cc's or 30 cubic centimeters is 30 milliliters. And we're going to get into units here before too much longer. But I was kind of hoping to blow people's minds, but apparently I didn't. Okay. Well, that's what cc is. Yeah, that's what cc is.
That's cool.
So this is my addiction. Not the Coke, the rum. It's a joke. It's like a joke. It's just smaller. This particular bottle, if you can read that, is 500 milliliters. It means that this is 500 milliliters when it's full, which of course is not entirely full, but you know. 500 milliliters is 500 cubic centimeters or 500 cc's stat. All right. Always properly recycle and dispose of your bottles. Any questions about that so far?
Nope.
So why chemistry? And why did I just get Diet Coke all over my tablet? I used to love to ask my students this question. When I went to the University of Cincinnati and got my bachelor's degree, which is this one here, I went to the University of Cincinnati. A university is a collection of colleges. A college is a specific set of disciplines that are all related to each other. So you have a school, a college of nursing, and all they offer is nursing colleges, or a medical. I used to teach at a medical arts college, and everything they did was related to the medical arts. That's a college. A university will have a series of colleges. So they might have a medical college at the university. They might have a liberal arts, but they might have a liberal arts college at the university. They might have an engineering college at the university. Look, 3D. Woo! Anyway, my university had a college of arts and sciences. And I used to love to challenge my students by asking a very simple and obvious question. What's the difference between art and science? it sounds like a trivial question, but it's not. I would ask my students this, and the first thing they'd say is, well, science is experimental based. Okay, that's true, but so is art. There's a lot of experimental artists out there. Every time an artist creates a new piece, they're experimenting to see if they're getting across the concept that they want. So yeah, they both do experiment. So it's kind of an interesting question to challenge yourself with. Anyway, to me, the way I answer this question, and I've had people argue with me that I'm wrong, and who am I to say? Maybe I am. My artist friends tell me I'm wrong. But to me, the difference between art and science, art is trying to express something. You know, in art, they're trying to express an idea, they're trying to express a vision, they're trying to express themselves. Well, whereas a science is trying to understand the world, you know, and I can see where on some levels art is trying to understand the world as well in a very different approach. But to me, an artist is trying to express the way they understand the world. Science is trying to understand the way things work. So when I think about science, I often think about a tree. The soil in the tree is mathematics. The soil feeds the tree. And for some reason, mathematics is very science-based. Lord Kelvin, if you've ever heard the term Kelvin before, we're going to work with Kelvin a lot. It's a temperature scale. Lord Kelvin was a real person. And he said, if you can put a number to that of which you speak, then you know something about it. If you cannot, then you know nothing at all. Science is very mathematically based. Why? I have no idea. God knows, I suppose. Kind of looking forward to someday meeting God, and that's one of the questions I would like to ask is why is everything mathematically based? And I'm kind of hoping that she'll give me an answer just before she pushes that button and sends me back down in the other direction. Anyway, so mathematics is kind of the soil of the tree. It feeds the tree of science. The roots of the tree are physics. It may surprise people to hear me say that chemistry is not the most basic science, because it's not. The most basic science is physics. Physics is the study of energy. My physics friends may say that I'm being a little too casual with that definition, but it's basically correct. Physics is the study of energy. Without energy, there's nothing. It's hard to see energy. You can feel it, you experience it, you can tell now the room is getting hot because I had to close the door to keep the damn cat out. But energy, you can experience it, but you can't really see it. You can't hear it. I mean, you can hear the effects of it. You can hear crackling if there's a electrical short somewhere. But Einstein proved that there is a relationship between energy and matter when he wrote his famous equation that I'm sure you've seen. Energy is equal to matter times the speed of light squared. Energy gives rise to matter. So without energy, there's nothing else. The problem, the only one, it's not even really a problem, but this is why I love physics so much. But the thing with physics is it's very esoteric because you can't touch energy. You can't taste energy. Chemistry is kind of the trunk of the tree. Chemistry is a study of matter, which we just discussed. Matter is everything that we can see, touch, smell, feel, wear, sit on. Everything. My cat star is matter. So matter is basically the foundation of all of our experiences, because we deal with matter every day. The computer that you're watching me on is matter. And because everything else is made of matter, then all of the branches in the tree, these are all of the other sciences. They are all based on chemistry, biology. My cat was just being a royal nuisance, and I had to close the door to keep her away from my camera. My one student here on break told me she has seen more cat butt right now than she's been wanting to see in her entire life. I apologize for my cat's butt. And is my cat biology? Well, yeah, biology is the study of living things. So yes, my cat is biology, but biology, because my cat's made of matter, it's also based on chemistry. The new telescope that's up there, what's the name of that telescope they just put up? Can't think of the name of it right now. It's the next step up from the Hubble telescope. Astronomist. Anyway, that's all chemistry, because every planet, every star is made of matter. So it's based on chemistry. My friend, the geologist, geology is based on chemistry, because rocks, rock formations, water, even the gases that make up weather patterns, that's all matter. So chemistry is sometimes called the central science, because everything is based on chemistry. Okay. And I just looked at the clock, and I think we're supposed to end at 11:20. So rather than trying to, actually, let's talk about one more thing about matter. Matter is often categorized by states. What do I mean by states? What are the states of matter? I'm a very quiet student.
Solid, liquid, gas.
Yes, Illinois, Chicago is not a state. Illinois, Massachusetts, New Jersey. Solid, liquid. I think we have time to cover this. And gas. Now, chemists love to actually define things. So we all know what a solid is. We all know what a liquid is. We all know what a gas is. Or do we? Is glass a solid, a liquid, or a gas? Glass feels like a solid, doesn't it? And yet, even amongst chemists, there's a huge debate as to whether glass is actually a solid or a liquid, because of phenomena. If you have a lot of glass rods in a chemistry lab, you will notice that over time, the older ones all seem to be bent. If you look at glass in an old house, the panes of glass are always thicker at the bottom than they are at the top if the house is really old. But is that because the glass is flowing? Or is it because graduate students naturally tend to avoid the bent rods when they are going to get a glass rod and they prefer the straight ones? In old houses, they didn't have great manufacturing facilities. They weren't as good as glass is today. So maybe the old builders just naturally put the panes with the thicker end down because it's just more stable. So we're debating as to whether or not glass is a solid or a liquid. A solid is anything with fixed volume and fixed shape. When I came into this room, I knew that my chair would be in the shape of a chair. It has to be. That's what makes it useful. That's why I chose it, so that it would always be in the shape of a chair. But liquid has fixed volume, but a variable shape. Liquids will assume the shape of the container. This Diet Coke will always, until I drink it, until I open it, this Diet Coke will always, always, always be 500 milliliters. Doesn't matter if it's on its side, if it's right side up, if it's upside down, it's 500 milliliters. But the shape, it assumes the shape of the bottle. So it has these funny little five divots on the bottom. It has this, if I hold it upside down, it has this funny cone shape. So liquid has a variable shape. What do you suppose a gas is? So a gas has variable volume and variable shape. A gas will expand to fill the volume of its container. This is more than 500 milliliters for the bottle. They put 500 milliliters of liquid in here, but there's always that little space at the top. So the gas that's in here has expanded to the volume of the container, and it has the shape of the container. I don't have anything else that would hold a gas, but that's the difference. So you can understand, just ask yourself what's variable and what's fixed. Fixed volume, fixed shape, solid. By the way, glass is a separate state of matter. When we think of states of matter, people think of three, but there are states that people don't realize is there. The plasma state, for example, is so hot that atoms are falling apart. That's a special state of matter. So these are not the only states. These are the major states of matter and the ones that we will deal with in this course. And that brings us to 11:20. Thank you for your attention and your participation. Are there any questions before we break?
No questions, but thank you for doing this for everybody.
Thank you so much. I will see you on, I hope I will see you on Thursday. If not, I'm going to be sitting here lecturing to myself. Have a great night.
Bye.